Hey y'all, I'm in Maine and my daughter is going to be giving birth soon, and actually we're going to be having a blizzard coming up pretty soon. It's kind of revving up for it. As you can see, there's already a ton of snow, but anyway, things just seemed really iffy as to whether I'd be able to do Google Meet tomorrow, so I decided to go ahead and do a video, and I'm just going to be going over the notes that I gave you, and just want to remind you that you have a test next week, and your notes explain that. Your homework will prepare you for that. Just remember that is your last test of the quarter, and you need to do your very best to try to get ready for that. And if you have any questions during the week, please email me and I will help you out with that. So we're going to get started. Okay, so we're going to talk about the distance formula, and we've already been finding the distance between 2 points using the Pythagorean theorem, which states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So we've been using the Pythagorean theorem just like this. If we have 2 points, like for example, -2, 3, and 4, -4, and we want to find the distance between those 2 points, we can't just count the squares because it's not a vertical line and it's not a horizontal line, it's a slanted line. The way we've been doing that is we have been drawing a horizontal line, which is the difference in the x-coordinates, that's its length, and a vertical line whose length is the difference in the y-coordinates. So that horizontal line there is -2 minus 4, which is -6. And that vertical line is 3 minus -4, which is 7. And then we know the lengths of the legs. So if we take the sum of the squares of those two legs, a squared plus b squared equals c squared. So 6 squared plus 7 squared is equal to d squared. 36 plus 49 is 85. That's d squared. So if we take the square root of 85, that is going to be the distance between those 2 points. That is an irrational number. That is the only way that you can express it. Do not punch it into your calculator and get a decimal approximation. That is the exact distance between those 2 points. So the distance formula is just a simple way to express what we just did without drawing the picture. So the distance between the points x sub 1, y sub 1, and x sub 2, y sub 2 is equal to the square root of the difference in the x-coordinates squared, so x sub 1 minus x sub 2 squared, plus the difference in the y-coordinates squared. So y sub 1 minus y sub 2 quantity squared. All you would have to do would be to plug in those coordinates into that formula to get the distance between the 2 points. So if we have this problem where we want to find the distance between the points 4, -2 and -5, 3, we would take the square root of the difference in the x-coordinates, so 4 minus -5 quantity squared, plus the difference in the y-coordinates quantity squared, so -2 minus 3 quantity squared. And if we add all that up, we're going to have 9 squared plus 5 squared, and that's going to be 81 plus 25, square root of that, and that would be the square root of 106. The square root of 106 is not reducible because there are no perfect squares in there. In fact, 106 is just 2 times 53, and 53 is prime. So there's no way to reduce that radical. You would just leave that answer exactly like that. Okay, the ideal gas law, another gas law. We've done the gas law, P1 V1 over T1 is equal to P2 V2 over T2. Now we're going to do this ideal gas law, PV equals nRT, where P is the pressure of the gas, V is the volume of the gas, T is the temperature of the gas, N is the number of moles of the gas, and R is the gas constant, 0.0821. And you might be wondering, what is a mole? Well, a mole is a word that's kind of like the word dozen. When you have a dozen things, you have 12 things. When you have a mole of things, you have exactly 6.022140076 times 10 to the 23rd things. So why? Why would I care? Chemistry, that's why. When we talk about atoms and molecules, we want to talk about how many we have, and we want to relate that number of molecules to the weight of the molecules. When you're dealing with the tiniest bits of matter that exist, it takes a whole bunch of those little buddies to weigh even a few grams. That's why this is such a humongous number. And so you'll learn more about that when you take chemistry, but I just wanted to give you a hint about what a mole is. So let's just see how we would use that formula. So we're going to use the relationship PV equals nRT to find the number of moles in an amount of gas when the temperature is 273 Kelvin, the pressure is 1 atmosphere, and the volume is 8 liters. And R, whenever you see R in this formula, it's just 0.0821 every single time. That's called the gas constant. It's just, this is how it works out. So we've got P, V, N, R, and T. Find the number of moles is what we're trying to find. So that's our N. That's what we don't know. And the temperature is 273 Kelvin. So we'll put that in for T. The pressure is 1 atmosphere. And that goes in for P. And 8 liters is the volume. And we put that there. And then 0.0821 is R. And now we just write the formula. PV equals nRT. Put all those numbers in. 1 times 8 is equal to N times 0.0821 times the temperature, 273. Now we have 8 is equal to 22.4133 N. And if we divide both sides by 22.4133, we're going to get that N is about 0.357 of a mole. 88.3, use the relationship PV equals nRT to find the volume of 0.832 mole of gas at a pressure of 3 atmospheres and a temperature of 400 Kelvin. R is still 0.0821. It's always 0.0821. So P, V, N, R, and T. We have that the volume is something that we're looking for. We're trying to find the volume. And then we have 0.832 of a mole. So we'll put that there. And we have pressure of 3 atmospheres. That goes in for P. And a temperature of 400 Kelvin. That goes there. And R is 0.0821. So we just put that in. PV equals nRT. Plug everything in where it goes. 3V is equal to 0.832 times 0.0821 times 400. We multiply all that out and divide by 3. We are going to get that V is about 9.12 liters. So that's all you have to do with that gas law. All right, now we're going to talk about conjunctions. A conjunction is a pair of inequalities connected by the word and. The graph of a conjunction includes only values of the variable which satisfy both inequalities. So, to graph a conjunction, we have to be very picky. We're only supposed to graph numbers that would work in both of those inequalities. So this is an exclusive group of values that have to live up to 2 conditions. Only graph the values that would make both inequalities true. Okay, so that's a conjunction. This is tricky because we're going to also talk about disjunctions, and you don't want to get confused because it's easy to get confused on these. So conjunctions, remember, are more exclusive. You're only graphing values of x on your number line that would actually work in both inequalities. So we want to graph the values of x such that negative x minus 3 is less than or equal to negative 2 and x minus 2 is less than 1. Now, pay attention to this d equals integers over here. We're talking about the domain. Remember, we talked about this before. When you graph your some function on the number line, you only want to graph according to that domain. Only include values that are in the domain. Remember, the integers are all the numbers that don't have a fractional part. They don't have any irrational parts. They're just whole numbers, positive, negative, and 0. Those are the integers. So when you graph integers on your number line, you're going to be using dots. You're not going to have any solid lines. You're going to be using dots. So you want to graph these 2 inequalities, but you only want to graph the values that work in both inequalities. So the first thing you're going to do is solve for x in these inequalities. So this first one, you've got negative x. You're going to add 3 to both sides. So that would be 3 minus 2 on the right. And you'd have negative x is less than or equal to 1. And now you've got to multiply both sides by negative 1, which means you need to flip that inequality sign. You just flip it. You don't do anything else to it, but flip it. So you're going to have x, positive x, is greater than or equal to negative 1. So you want to graph those numbers, but you don't want to, you have to pay attention to what's going on in the other inequality first. So for that one, we're going to solve for x by adding 2 on both sides. So we're going to have x is less than 3. So you want integers only. Let's remember that. Integers. So you want to graph all the integers that are greater than or equal to negative 1 and less than 3. So could be negative 1, it's greater than or equal to, so it could be negative 1. It could be 0. Keep going up, could be 1. Could be 2, but it can't be 3. X has to be less than 3. So those are the only integers right there that are both greater than or equal to negative 1 and less than 3. So that would be how you would graph that conjunction. Okay, we want to graph this conjunction, and this is just another way to write the conjunction negative 2 is less than x minus 2 and x minus 2 is less than or equal to 4. So instead of writing that x minus 2 twice, once in the first inequality and again in the second inequality, this is just another way to write it. So you don't have to put that and. You're just saying negative 2 is less than x minus 2, which is less than or equal to 4. So it's just another way to write it. Now, notice our domain is reals. That means that we're talking about any kind of number on the number line. And so first of all, we know that we have to solve for x before we can do anything. And this time, when we're solving for x, it's going to be kind of like we have 3 sides of our inequality. So we're going to add 2 to all 3 of these groups here. We're going to add 2, and add 2 over here. So that's going to be 0 is less than x is less than or equal to 6. So we're graphing all the real numbers that are between 0 and 6, not including 0. So this basically says x is between 0 and 6. It could be 6 because it's less than or equal to 6, but it can't be 0 because it's got to be greater than 0. 0 is less than x. So we don't want to include 0, but since we're in the real numbers, the only way we can show that we want to go right up against 0, we want to get as close to 0 as we possibly can, we can include any number that's smack up against the right side of 0, but we don't want to include 0. The only way to show that is to put an open circle on 0. All right, and then you're going to include all the numbers on the number line up to 6. You can include 6, so put a solid dot on 6, and that's it. So that's a conjunction. You want to graph all the numbers that work in both inequalities. All right, now we're going to talk about disjunctions. A disjunction has 2 inequalities connected by the word or. To graph a disjunction, we're less picky. If a value of x only makes one of the inequalities true, we graph it. One or the other, both, it doesn't matter. It's all good. Everybody gets onto the graph. As long as the value fits into at least one of the inequalities, we graph it. So we're going to multiply this first inequality by negative 1 on both sides. So that negative x becomes positive x. We flip the sign because we always do that when we multiply by a negative number. So we just turn it around and make it less than or equal to, and then positive 3 becomes negative 3. And then the other inequality, we're going to do the same thing. We have to multiply by negative 1 to get x by itself. So positive x, flip the sign, is greater than 1. So we want to graph any x's that work in these 2 inequalities. So x less than or equal to negative 3, we're talking about real numbers now, not integers. This means any number on the whole number line is fair game. But we've got less than or equal to -3, which means it can equal -3. So we're going to put a solid dot on -3. And then any number less than that. So we're just going to color that number line all the way down and put an arrow there. And that's it. Those are all the numbers less than or equal to -3. Now we want to graph the numbers that are greater than 1. We don't want to include 1. It doesn't say greater than or equal to 1. It just says x greater than 1. The only way to show that we want to get smack right up against 1 is to put a circle on 1. And the only reason we're doing that is because our domain is the real numbers. Remember, we never ever put an open circle when the domain is integers. Only when it's real numbers, because with integers, you don't get smack up against something. You just go to the next integer. But when you're talking about real numbers, you're trying to show, yes, even 1.000999999 can be graphed. That's still greater than 1, but not 1 itself. So put an open circle on 1 and color everything greater, and that's it. So when you have a disjunction, you're going to have kind of two lines. You'll have the first inequality will be one of the lines, and the second inequality will be the other one. Raised, I guess I should say. All right? So that's how we do a disjunction. Let's look at another one. Okay, so 89.4, we want to graph -x minus 2 is greater than or equal to 0, or x plus 3 is greater than 6, and our domain is the integers. So we're going to solve for x. -x is greater than or equal to 2, or x is greater than 3. So we have to multiply the first one by -1, so x is less than or equal to -2, or x is greater than 3. So we want to graph all the integers that would work in either one of these two inequalities. So x is less than or equal to -2. That means it can equal -2, and it can be less. So anything all the way down and so on. Integers only, all right? Or x is greater than 3. Do we put an open circle on 3? No, we do not. We do not do that when we have integers, only when we have reals. So if x is integer greater than 3, that means we start at 4, and then 5, and 6, and so on. So we have two sets here. We have two groups, and that's all it's always going to be when you are doing a disjunction, when you have the word or. Okay, lesson 90, 3 equations and 3 unknowns. When we have 3 equations with 3 unknowns, and all 3 equations like this, x plus 2y plus z is 4, 2x minus y minus z is 0, 2x minus 2y plus z is 1. What we have to do here, our main goal, is to reduce this down to 2 equations with just 2 unknowns. Because once we do that, we can proceed as usual. We can solve that system of equations by elimination or substitution. Everything's good. We already know how to do that. But our first step, when we have 3 equations with 3 unknowns, our first step is to use 2 of the equations to eliminate a variable. If you look at these equations, probably the easiest variable there to get rid of would be z. You could use elimination. And our second step is to use 2 different equations to eliminate that same variable again. Because once we eliminate z, we will just have x's and y's. We'll have 2 equations, 2 unknowns, and we already know how to do that. So let's see how we would do it. We have equation A. I'm calling them equations A, B, and C just so it's easy to talk about them and give them a name when I say them. So first thing we're going to do to get rid of the z's, we're going to get rid of the z's in equations A and B. So we'll just use elimination. So we've got x plus 2y plus z is equal to 4, and 2x minus y minus z is equal to 0. And when I add those 2 equations together, the z's cancel out, and I just end up with 3x plus y is equal to 4. Okay, so I'm going to put a circle around that. That's one of my 2 equations that I'm going to solve in the end. Now, if I take b and c and I cancel the z's again, then I'm good to go. Don't try to cancel something different. Don't look at b and c and say, oh, look, I'll just subtract those and the 2 x's will disappear. Don't do that. Eliminate the same variable. So I'm going to take b and c, and I'm going to eliminate those z's again. So we've got 2x minus y minus z is 0, and 2x minus 2y plus z is 1. So I'm going to add those together, and I'm going to have 4x minus 3y is equal to 1. So that is my second equation with two unknowns. And now I can just solve that system of equations. 3x plus y equals 4, and 4x minus 3y is equal to 1. So there they are, and I already know how to do this, right? So if I multiply that first equation there by 3, I'll be able to cancel the y's because there are negative 3y in the second equation and just 1y in the first equation. So I'm going to multiply that whole first equation, both sides of the equation, by 3, and I'll have 9x plus 3y is equal to 12. Don't forget to multiply the constant by 3. It's very easy to forget to do that. And then you've got 4x minus 3y is equal to 1. So add it up, you got 13x is equal to 13, which means that x is equal to 1. And if you plug that back in to either of the equations that we had over here, I'll plug it in to 3x plus y equals 4. So 3 times 1, 3x plus y equals 4. So y is equal to 1. So I would write my answer. Well, we have to find out what z is. I forgot about z. Right, let's go back and find z. So x is 1, y is 1. Let's see what z is. If we put it into this equation right here, we put 1 in for x, plus 2 times 1, 1 is y also, plus z equals 4. So you've got 3 plus z. Sorry, I'm making a mess up here. 3 plus z is equal to 4. So z is also 1. So you would write your answer as a coordinate triple, x, y, z, 1, 1, 1. That would be your answer. Okay, we have another one right here. Again, this one is probably, I would say, easiest to get rid of the y's because you have some positive y's and some negative y's, and that makes it a little bit easier. So let me name the equations. We'll call the first equation A, B, and C. All right, first thing we're going to do is multiply equation A by 2, and then we're going to add it to equation B. That will cancel the y's. So I'm multiplying the first equation by 2. I'm going to get 4x minus 2y plus 6z is equal to 18. And then I'm just going to take the second equation as it is. Just use second equation, b. So that's x plus 2y plus z is equal to 8. And I'm going to add those together. So that's 5x. The y's disappear. And that's plus 7z is equal to 26. So that's my first equation in x and z. I need another equation with x and z, so I need to cancel y's again. All right, I can use equations b and c to cancel the y's because I've got positive 2y and negative 2y. So that's easy. So now I'm going to add equations b and c. So x plus 2y plus z is equal to 8, and x minus 2y plus z is equal to 0. Add them together, and you get 2x plus 2z is equal to 8. And so before I have two equations now in x and z, and I'll be able to solve using those. But first, I'm going to just divide this whole equation through by 2 because it just makes it easier. It makes it an easier equation to deal with. I noticed that there was a common factor of 2 everywhere, so I'm just dividing everything by 2. So now I have my two equations. I've got x plus z equals 4, and I've got 5x plus 7z is equal to 26. X plus z is equal to 4, and 5x plus 7z is equal to 26. And then I'm going to use elimination or substitution, it doesn't matter which one, to solve this system of equations now. I am down to 2 equations and 2 unknowns, which is what I was trying to do. So I'm going to multiply the first equation by -5. I just like elimination better, if possible, but you can do it either way. So I'm going to rewrite that first equation that I'm multiplying by -5. So -5x minus 5z is equal to -20. And then 5x plus 7z is equal to 26. So we're going to add it all up. We'll have 2z is equal to 6, which means that z is equal to 3. If I look over here, I can see that x plus z is 4. That means that x plus 3 is 4, which means that x is 1. So I've got my x, which is 1. I don't know my y yet. And I've got z, which is 3. So I'm going to go ahead and put that there. And then I can go back and find out what y is. I'm going to use, it doesn't really matter. I'll use the first equation. So 2 times 1 for x minus y plus 3 times 3 for z. That's supposed to equal 9. So 2 minus y plus 9 equals 9. So 2 minus y equals 0, which means that y must be 2. So y equals 2. And there it is. 1, 2, 3, x, y, z. Okay, so your homework is on your notes. Make sure you do the problems in that order so that you can be sure you know how to do each type of problem. That way you will be able to focus in on each type and make sure that you know how to do each and every type. And that way you'll be prepared for your test. And that's going to be your last grade of the quarter. And that'll be a very important grade since we haven't had very many quizzes, and it's an important grade. So really, really work hard and contact me by email if you have a question during the week, and I will go over that. Have a great day.